Hi everyone, Gert van Brugink, Sherman Chu, and we're going to share some cool stuff with you. So thousands, if not millions of years ago, what we kind of did was paint pictures on walls, And now, fast forward to the present, what do? We create 200-page reports that no one reads. Pretty interesting. We can do better. And if we translate that situation to cyber threat intelligence, those who know my approach to things and also Sherman's approach to things will recognize that CTI is not just about indicators or let's say techniques or procedures. It is also about making conscious decisions. And I've been a big fan, and I really think that CTI should evolve more towards decision-making or decision support practice rather than just purely focusing on intrusion analysis. Evolve more, just like Darth Vader. We lift people up so that they can make better decisions. That's what we do. And in the context of what we're going to talk about today, I think there's a couple of situations where you could that all of us probably have been in. Figuring out what to do about the next vulnerability. Figuring out, okay, we have to support the incident response team in telling them what to do. What's going to happen next? How does that even work? How do you know that? Or even supporting people and making choices about what they need to invest in. To defend against everything, we need $100, but our budget is $4. Good luck. That's the use case. A lot of us actually have that use case. And sometimes, even when you're protecting an organization, you gotta think on your feet, And especially if there is a big project you're launching, or new service, or I don't know what, but it could be that you have to make quick decisions, and you don't have the time or the luxury to spend a lot of time analyzing, thinking it through. Sometimes you just gotta respond to the situation as is. And that leads us to why attack trees.
Thank you. All right. So why attack trees? Okay, so let's talk about why attack trees were created in the first place, and we'll do a deep dive into the history behind attack trees, or AKA threat trees. But essentially, attack trees are a conceptual diagram that really helps visualize how a target / an asset can be attacked, right? It really helps us threat model it out, right? The different routes an attacker needs to take in order to achieve their objectives. Ultimately, it's to support defensive decision making, right? Help us understand where do we want to prioritize our efforts, our resources to thwart or stop the attackers from actually achieving set objectives. And with that said, let's just pivot a little bit and talk about the history here. We're two nerds, we love our history. We like to do a lot of research, but let's rewind time and go back to the 1980s, right? So the attack tree is actually not nothing new. It's been around for a hot minute. What's it now? 40-some years ago, 1982, right? When Jonathan Weiss was, I think that's the first person, at least I found, right, to have published this article, long form article on attack trees and how it can help with IT sort of security assessments. Fast forward to 1999, we see Bruce Schneier again on his blog. And by the way, blog existed way before even internet was a whole a thing. He also talked about attack trees as well, right? Really talking about the systematic sort of process and assessments of threats. And between then and now, obviously a couple of decades have passed by, but we've seen a lot of development and evolutions of different frameworks, methodologies, right, to help us really assess threats, both from a more complicated perspective, and as well as a deeper dive into how do we apply defensive courses of actions, right? Now, 2025, two nerds at a CTI conference, trying to really bring all this together for y'all so that you guys can also apply this, hopefully in your own endeavors to really protect your own organizations. All right, so now let's talk about attack trees and why do they look like the way they do, right? So classical attack trees are basically multi-leveled diagram, as I mentioned, that ultimately tries to solve, how an attacker might achieve the end objective, which in this case, at the very top, we would like to call it, we'll call it the root node, right? The end objective. Here you can see an example, more applicable for modern, recent times. Does anybody know what this is? Something about IT workers trying to access, from another country. So this is a very truncated, abridged version of this, but we can also use attack trees to map it out, right? But with any classical attack trees, what we have is a bottom-up approach. Bottom, you can see all these child nodes, right? Child nodes needs to be satisfied in order to make the parent conditions or parent nodes true. So we'll walk through this. So actor will need to either have to use remote tools or KVM over IP to access their enterprise laptop that's situated in a laptop farm, right? And then in order to access enterprise network, they have to use that laptop or have control over the laptop to access enterprise network. So it's a cascading sort of like if true, then go up to one level sort of situation here. Now, obviously, attack trees, classical ones at least, are very single objective oriented. We all know that in real world, threat actors have concurrent and multiple objectives, sub-objectives that they need to achieve, right? Cue in the other different taxonomies that we have developed across the decades. And these are just obviously some of the examples here, and really just between the 2010s, right? First, we have kill chain, which is a very truncated approach of looking at attacker sequences and phases. We also have Diamond Model of Intrusion. By the way, I'm pretty sure I'm checking a lot of boxes in the bingo card for this. But like once again, the Diamond Model of Intrusion here, right? It's a deeper dive into events, each action that the attacker takes, breaking it down to these four core features: adversary, infrastructure, victim, capability. Last but not least, we also have MITRE ATT&CK, right? Which is really helping us understand or share the language in a standardized format of threat actors, TT, and procedures as well. And we can bring all these together. So you can see this is actually an extraction from the Diamond Model of Intrusion's white paper, where we're actually bringing in all the methodologies that we have just mentioned together, right? On the left, you see the kill chain being used, once again, in a truncated format to look at attacker phases and sequences. Diamond models there to depict each and every behavior / event / diamonds and how they can relate to each other, how they can flow into other events and other actions. Obviously, MITRE ATT&CK there really helps us to standardize the way in which we describe tactics, techniques, and procedures. Well, procedures now is basically the diamond itself, right?
Yeah, I think the last time we actually gave this talk, and so just to be clear, Sherman and I research this on a daily basis. So we're pretty, I would say, we know a few things about it. But the one thing we've learned, and actually we saw that yesterday as well, it's interesting to share a methodology which will explain to you why you need to do something, but and how you do it. But then what can you do tomorrow? And we had the same issue because conceptually, the previous slide, it's a great model. This is what you can use at home. Think of it, use it as a mental model. But practically, we started using the thing called attack flow for this sort of thing, to map out these attack trees, basically. And that allowed us to basically create a canvas that we can model everything into. It allowed us to plot more details into it, really making it tangible for all the people we actually work with. And in fact, there's even for the purists, because obviously there are official formats for when you export into a attack tree format. Fortunately, the attack flow tool actually supports you in making those exports. In this case, you can use it in GraphViz or Mermaid, and you can also export it into JSON so that you can use it in any way you like. You decide. That is possible now, and we're a big fan of that. But what do you do with it, right? Sherman explained, what it is, where it's coming from, but what can you actually do with attack trees? And one of the fun things I personally think is the biggest value of it is not just thinking about what we know about something, but also figuring out what we don't know. And you wouldn't believe how many people actually don't do that, like having a conscious, thought about, we know this, but what don't we know, right? Constant contemplation allows for postulation. I had to look up the word. It was a very sophisticated word. But the thing is, you actually look at what are we missing? What are other blank spots we might have and model that out. And this kind of logic, this kind of mental model allows you to explore new paths or things that you can actually see, or even develop hypotheses that you think are useful to test, to validate. And that's the beauty of these kind of attack trees. You can actually do that as well. And the beauty is, if you've done that exercise, you can actually decide where you want to defend. And this is also like an interesting thing, because technically we want to defend everywhere, right? But the reality is, to defend against everything, we need $100, but the budget is $4. So you have to make a decision. So if we move to the as early as possible, maybe we should figure out what the cost would be. But anyway, we can then, cut the cord at the top and everything else stops. And with attack trees, you can make that really visual and practical.
Right. Yeah, and then there's some also methodologies out there that's already been sort of developed, right? That really help us understand how do we prioritize. Here, we're actually borrowing from the MITRE's Center for Threat Informed Defense, CTID for short. In there they have this top attack techniques, right? And they broke down the methodology, and it's a really good read. And I encourage everybody here to just go read it yourself. But long and short of it all, it's a formula, right? There's prevalence, choke point, actionability, and we'll actually run through this later down in the walkthrough. But in short, prevalence is how often the attacker would use a specific technique over time, right? So the more often it is, the more prevalent it is. Choke point, every technique out there will flow into another technique, right? So you can quantify that. Some techniques will there's some techniques have a lot of techniques that will flow into it, and then subsequent of that successful execution of that technique, you have a lot of options available as techniques after the execution. So that's choke point. Actionability, how easy it is for defenders to prop up detections, preventions, or mitigate the whole technique. So if a technique itself requires some prevalent data sources, or have a lot of detections already out there available for you to refine and customize, that's high actionability. Maybe there's a lot of NIST-related controls, high actionability. When you combine all these three together, you get this sort of like prioritization of techniques that you can use to also help with your prioritization of defense. Yep. And speaking of that, there is that data out there that's available. I think CTID has broken out that calculator and the sort of the numbers behind it, the weights, right, available as Excel. So as I said, please feel free to go peruse yourself. It's actually a really great tool. But yeah.
And just to be clear, we're not being paid by CTID, but John sent us T-shirts.
Yeah.
That's a different story. We're a big fan of everything that is open source, and we think that these things we do, they shouldn't cost you $1 million, but there's a lot of stuff out there, folks. Share it whenever you can, right? That's what we're trying to do here. Invitation to all of you, by the way. But when continuing on what Sherman just said, like it's great to have this kind of metrical, decision support function, but then you have to consider, like, if we stop if we enforce a certain policy because it actually makes sense, we might hamper business operations, right? And that could, so I sometimes refer to this kind of logic as, what is the minimum viable company that we would need to actually run the company? And how would this then allow us to think better about where we defend consciously and how we do that? But this is the sort of thing that an attack tree actually helps you facilitate that discussion. Yeah, and let's show the people a bit how we do it in practice, right?
Yeah.
I think that would be good. We're on the clock, so that's good.
Yeah, more time than I thought.
More time than we practiced.
Yeah.
So the interesting thing is, when you build attack trees, actually this is a pretty tedious process. Not gonna lie. And when we do presentations, it all looks fancy, but the reality is, as with all research, it's dirty. It takes time. Everyone probably recognizes that. You have to do pivoting. You have to go from a file to a document or whatsoever. And sometimes you're doing that when you're under duress. You're managing an incident, and all of a sudden you have to write all sorts of stuff. You don't have time for this sort of thing. But there was an interesting take in the keynote today that also was about taking a moment, slow down, think about your team, think about how they operate, And that logic applies similarly to attack trees, taking a step back so that you can make 2 steps forward. The only thing is, sometimes you just got to roll with the punches and figure it out. Sometimes you have time to think and model that out. And sometimes you have the opportunity to work with your team and then really work through like different scenarios, think it through. But sometimes you have time and sometimes you don't. And again, I want to emphasize again that the being explicit about what you know and what you don't know. I also think that there's a lot of heat around that it's bad to not know something. In fact, I think that is actually a strength if you're able to articulate that. And that is something I think we should do more as an industry, be able to articulate that, yeah, I know this, but I don't know that. And we found that to be very powerful. And especially in factories, when you postulate, for example, that is really useful. And yeah, where do we do that? So we used to do it on the whiteboard, right? And then that was messy. And I think it's also for other structured analytical techniques or other methodologies. It's really like, where do you do it? And most of the time it is, on a collaborative thing, a low fidelity thing, which could be a whiteboard. It could be paper. There's more apps. You could do this in Lucidchart and Visio and Draw.io, all sorts of stuff that is either free or paid. We found attack flow, to be really useful for this sort of thing, and we do recommend you to explore that. Yeah, let's show how we do that.
All right. So it's already rolling. So right now, what you're seeing here is an actual a report from CISA that's going through APT40, right, with their historical observed behaviors and campaigns. So what we can do really is, and this is like more of a hasty thing, we want to map it out because it's a lot of writings. We can go in, we can read the report, and we can start extracting the key elements, right, the key behaviors, and then put them into attack flow as an object, right? Put in tactic, the technique number, and also slap in the sort of metadata or the interesting information here. As you can see, we're mapping out the reconnaissance technique that have been observed, right? So we can just put all that there. And you can also add confidence levels as well, if you so want to. So that's just one. We can continuously to add more, right? Based on the report, there's a lot of different techniques that you want to map out and then chain together, add the relationships. In this case, subsequent to reconnaissance is initial access, where APT40 has been seen exploiting custom web applications, right? Using web shells and all. So we can start slapping that in as well, right? With the added sort of flavor text and also like the actual intricacies of it all.
Okay. Is it okay if I add one more thing?
Yeah, sure.
So what you kind of not see right now is like the difficulty of going in one file and then going into the other and then, copying and writing, the analyst, you're getting crazy, And that sort of stuff, that is something we cannot capture in these presentations, but we do try to make it visual, but this is like a process, right?
Yeah.
It is very tedious to do such a thing.
Absolutely, and but the thing is, within at least the attack flow and some other tools that we can use, it's more dynamic. You can switch things around, you can add things, modify things, so you don't have to wipe the whiteboard again and then try to redraw that, right? Yeah. So it does save a lot of that reusability of it all. But all in all, though, like when I did this myself, to include the time that I read through the report, at least the first case study, right? It took me 30 minutes, approximately 30 minutes to really digest what they're trying to convey, the behaviors that APT40 have exhibited, and then mapping it out into, in attack flow, right? Obviously, you can't really see details here, but I kind of zoomed out and, basically hopefully be able to show you guys, that chain of behaviors, but, 30 minutes more or less. And I would say this is like for a first pass through, I think it's very usable, but we can always go back in and add more details. So if we want to take a deeper dive into some of these actions that the threat actor has exhibited in the past, we can also add in other frameworks. As I mentioned before, Diamond Model of Intrusion, while it is more of a mindset, I think as Sergio has said it himself, but we can also apply the same sort of characteristics and then further sort of expound on each of these attack, right? Here we can add the victim capability, adversary infrastructure features, and really now start breaking it down even further to provide more details for us to use as assessments. Obviously, we talked about postulation of events, right? In the report itself, it's very detailed, has a lot of information, but didn't really go through in depth of how did the threat actor themselves enumerate the victim's network. So we can postulate by adding, hey, it is likely that APT40 went through and enumerate through their AD, right, to get creds and all that good stuff. So we can definitely slap that onto the graph itself, right, to provide more probability, more possible of attack flows, right, to further make this graph more robust. So that's absolutely permitted and actually encouraged. And finally, once you have a good graph enough for you to assess or analyze, you can start doing prioritization assessments. Here, we'll start off with one of the more common techniques that's been exhibited by APT40, which is command scripting interpreter. In this case, through the web shell, right? All right, as I mentioned, we're kind of going through the formula that CTID provided in the top techniques. So we'll start looking at the prevalence and the choke points. So in the report, CISA basically listed out all the different variations of command and scripting interpreter techniques that they have observed APT40 doing, right? And it's quite a list of variations here. But with that said, we can consider this as a pretty prevalent example. Next, we know that command scripting interpreter is a huge choke point. Now, according once again to CTID's calculations, and they've done a lot of number crunching and a lot of ingestions of their own data. We know that 10 other techniques can flow before command scripting interpreter, but then successful execution of command and scripting interpreter, it's such a long name for a technique, can result into 15 other different types of technique, right? So it's a very high choke point. So imagine if you stop that from in its tracks, you're closing a lot of doors for the threat actor themselves. So high choke point. Third element here, actionability. So we'll just use Splunk's open source repo, for example. For them, they've listed out 73 different detections out of the can detections that they have available in Splunk. Now, just a caveat here: if you want to always go and refine and customize any default detections, because each org's environment is very different from each other, may lead to a lot of noise. But even then, 73 to start off with to refine yourself, it's not a bad deal, right? Also, we can look at controls. From a NIST 853 perspective, quite a few controls that we can use to sort of prevent threat actors from abusing command and scripting interpreter or PowerShells. Now, obviously, speaking of PowerShells, we also need to factor in business operations. We would all I'm pretty sure 80% of people here would love for us to completely block PowerShell from our orgs, right? It will probably save us a lot of heartaches. But we're gonna probably break a lot of business operations because we know PowerShells are often being used by sysads to run updates, to do a lot of scheduled tasks and all the good stuff. By blocking PowerShell, well, God save your soul. But
don't pitch that. It's a difficult thing.
Yeah. So the moral story here is always factor in the reality, right? And that is consult with your business operations, what can be in play and what cannot be in play, right? Because that will help us provide better recommendations as a CTI team to defenders, to red teamers to emulate as well. So.
Yeah, awesome. I think Sherman already alluded to it, but it's about conscious prioritization. Consciously choosing to do, we're going to defend here or we're going to defend there, or either maybe we want to defend at a different layer, right? Because the attack tree allows you to then visualize, maybe we want to defend, have the adversary actually come into the network, maybe, and then maybe trick the person or individual or group or whatsoever. And this basically gives you the insight to do that. Where does that leave us? So I think there's a lot of, when you do attack trees, when you model it, regardless of the tool, I think there's a couple of important things. So there's Originally, there's the traditional way of doing attack trees, which is the thing Sherman talked about in the beginning, right? That is the thing how we conceived it. Now, right, fast forward to the present, that might not work completely. For those of you paying attention, maybe online, maybe here in the room, you would have noticed that we didn't stick to the formal regulations of how to create an attack tree. And that is okay, you know, do what works, figure it out, change, update, evolve. That's exactly what we need to do. And especially when you're using these kind of visualizations, and we call it an attack tree, but whatever you do, be able to tell a story. And I think multiple people today already talked about that. In the previous talk, we had a great example of how to tell a story about, you know, this marketers. I love that. But also in the startup mindset session, I also think there's great aspects of how to tell a story to your CISO, how you be able to tell that. Well, I can tell you this, you know, people don't have to understand in the image on the left, people don't have to understand every single detail, but they do understand that if you, there's actually little red boxes in the middle. If you cut the red box, everything below stops. It's pretty simple, right? But still, we create 200-page reports to actually explain why this whole thing is super important and why we're such good researchers. Most of the time, people don't care or don't have the priority for it to go over that, right? So for security decision-making, you got to show the full picture. But the thing Sherman and I learned a lot is we have to engage with detection engineering, with an incident response, with other teams, risk, fraud, you name it. And they just talk a different language. So we need to be able to also zoom out. We'll also be able to zoom in. So for example, if you want to do incident response, you basically want to know, hey, we got a web shell on the VPN device. You know, where do we move from here? And that actually, just modeling that out, that helps you to think backwards, think this is the things that could have happened, but also think forward in what could happen or where the adversary could already be. And hence also web oscillation could be so relevant. And then finally, you can decide, we're going to do something about that because the attacker is known to hijack RDP sessions, for example. So we better get some detection logic in there to actually figure that out. Or do we? Maybe we want to spend our time more wisely to do that. But this is, so how we are using it is to not just help decision makers in business and security to tell a whole story about a given scenario, a threat, a specific event that has happened. We translate that to the decision makers, the incident responders, red teamers to test. They can test attack sequences. And finally, we can also share that with very specifically not just the technique, but also the procedural level details, which is, as Katie mentioned, very important. But that is the sort of stuff we need to define exactly how do we want to defend on that. So that is how you can make the attack trees valuable for your team. Yeah, you probably already got the point, but just to reiterate, this is really this is a common methodology. It will stay around. It will evolve. Hopefully, Sherman and I have contributed a bit to your knowledge on that. But we really see it as a means to combine the storytelling between what is happening in the threat landscape and how can we translate that into what you actually can do about it. Really consider it as a mental model that you can leverage on a whiteboard, on whatever tool you're using, even on PowerPoint or Word or whatever floats your boat. We found it to be very useful to use the thing called attack flow. And actually, we recommend you to use it as well. Use it in your next incident response report. You'll be able to tag so much things to it. It is just useful and it works really well. So today, have a look into that, and tomorrow you can work on the attack trees. I'm going to end off with a final one, and that is a bit of a scoop that we were allowed to share. So the team behind Attack Flow is actually going to release a new version, and they're doing some development runs right now. So you can expect some updates on that in the next couple of weeks or months. But it's very exciting, and they're listening to the community. They're listening to people like us sharing back, and we do recommend all of you to use it. Give them the feedback as well. And actually, if you're working on some research, share it back as well. Because they love that, we love that, and that's what helps the community. Gertjan, find me at these social media things. I also curate a newsletter, just sharing some stuff. Sherman?
Oh, thank you, everybody. Yeah, and find me on LinkedIn. Most of the time I'm on Mastodon now, but I don't have the link for that. So, but we can talk afterwards. But aside from that, thank you everyone. Appreciate the time.